Last week, we covered how to create classes, and we used private fields and we used public fields. And with the private fields, you learned how to create get and set methods and how to place data in those private fields and how to retrieve data from them. With the public fields, we learned how to create the objects and access the field by using the object, a dot, and then the field name. There is another way to create private fields that fully encapsulates the private fields, and it is through C# properties. C# properties will have a public name similar to a public field. And then behind the scenes, C# will create a private field. It will create the get method and it will create the set method. It generates all of that code. So all you have to do is create the private property or the public property. And creating the public property is similar to creating a public field, but there is one main difference. When you create a public property, after the property name, in curly braces, you code get and set. And actually, there is no semicolon at the end unless you set a default value. So it's simply get and set, no semicolon at the end, because you have a semicolon after get and you have one after set. This example would create a private field ID, and it would create a get ID and a set ID method for us. And this little example would create a private field first name, and it would also create a get and a set. So to see how that looks, here we've got the auto-implemented property, and it is called auto-implemented because the private field, the get method, and the set method are automatically generated. Okay? And all you have to do is key in this portion. Do not put the semicolon after at the end because that will flag an error. So this is actually the proper way to code it. And then after you code it, when you compile, it actually generates all of this code that you see on the right. So one line of code for a property generates all of that, the code on the right behind the scenes. This does simplify creating classes because now we can just create public properties and then all of the extra code, the two methods and the private field are generated. And so this simplifies creating classes for us. To place values into our public properties, it is very similar to placing values into public fields. You still have to create an object, but what you would do then is do the object dot and then the property. And if you're going to put value into that, you just have an assignment statement. Okay, so there are no more set methods. And if you want to print it out, you do not need to use a get method. It is just the object dot and then the property. So let's take a look at some examples. So in this little example, we have an ID property. Our ID property is what it's called. And we haven't set it equal to anything, but you'll notice that for first name and last name, these are also public properties, and we did set them equal to string.empty. Okay, and by placing the get and the set inside the curly braces, that is how C# knows that it's a property and that it needs to generate the private field, the get method and the set method. So in our main program, we will access these properties the same exact way that we access public fields. Okay, so what is your ID? We read that in and we are placing it directly into our member object.id. What is your first name? We are reading that from the console and placing that directly into our member object.first name. For the last name, it's the same thing. We are reading that right in and we are placing it into member.last name. And then to print, we do not have to use the get methods anymore. We use our object dot and the property. Now, behind the scenes, what's going on is so we use member.id, and behind the scenes, C# knows that we are trying to access the private ID. So it runs through the code it generated, the get ID code, and it retrieves the ID and it puts it right here. So all we have to code is the object dot and property, and C# will do the rest for us. And this is a very similar example to the last one. This read input from the console, and this one does not. It's got the input just directly in an assignment statement. So you may be thinking, well, what if I have some special business logic and I want to change a Boolean value based on, let's say I need to know if I should reorder stock. And if the stock falls below a quantity of 10, then I need to reorder. You can create a property with business logic, but the syntax is a little bit different. So you will have to use regular property syntax. And with regular property syntax, there is a little more coding involved because you are going to be declaring the private field. And then you're also going to declare the property. But instead of, in your curly braces doing the get semicolon, set semicolon, you actually have to code those out. Okay. And so the get is pretty straightforward. I mean, occasionally you may have business logic in a get, but typically you don't. The set is more inclined to have business logic in it. And with the set, in a normal set method, you pass data that you want assigned to the private field. And so C# has actually set all of this up for us. And the data that is passed is stored in a variable called value. Okay, that is the name where the data is located. You don't have to declare it. You do not have to, put parentheses after set and include any data in the parameter list. C# automatically is generating this, and it is storing the value that has been passed. So you just take value and assign it to that private field. So here is one example, and then I will show you some more of business logic in the set, and I believe I have an example of business logic in the get as well. So for ID, that's just a normal property. Okay? Nothing special about this one. Department does have some special logic. You can see down here, if the ID is less than 200, the department is going to be sales. Otherwise, it is going to be whatever value was passed in. Okay, so because we have the special logic, we have to create the private field. And then after we declare our property, inside the curly braces where we normally have the get semicolon set semicolon, we have to kind of flesh out get and set. So we code out get, which is just returning the private variable. And then we code out set, and this is where we have our if else. So if the ID is less than 200, then we're going to assign the private department field the value of sales. Otherwise, it is going to get whatever value was passed. And we will take a quick look at this. So this example is exactly what you just saw for the class. And then in addition to ID and department, we also have first name and last name. Those are both public properties, and they happen to be strings. So then in our main program, how many employees do you want to enter? We basically have an integer to store that. We read the value into a string. We use try parse to make sure they entered a whole number. So we kind of run the input through that. As long as they entered a whole number, it'll get stored in max. And then we will go out of the loop. We'll declare a counter. And then we're going to stay in this little while loop as long as the counter, which is the number of employees they've added, is less than the maximum they entered. So we create an employee object. We ask for the ID. And here we are creating a temporary ID. And we have that error handling while loop. You'll notice there's one difference in this one. Instead of reading from the console and storing the string in a temporary variable, what I'm doing in place of the string variable is I just have a console.readline. That will read in the string, and it will feed that string into try parse. Try parse will try to convert it to an integer. If it can, then it stores it in temp ID. And if it cannot, then it says, please enter a number, and that console.read executes again. So we'll stay in this loop until they actually enter a whole number, in which case it will be stored in temp ID. And we fall out of here, and temp ID goes into employee.id, and ID is the property. Then we want the employee department, and that is a string. So we read it in, we store it in employee.department. For first name, we're doing the same thing. It's a string. So we prompt, read it in, store it in employee.firstname. For last name, we do the prompt. We read it in, and we store it in employee.lastname. Okay, and then we write everything out. And then you might be thinking, well, when does that department name get set? So when we change the department, what it does is it automatically comes through here. And if it'll check the ID, if that is less than 200, the department is set to sales. Otherwise, it is going to use the value that was passed. So here, I said I wanted to add 2 employees. I did a bad number, and so it caught it. And then I did the number 10, which is less than 200. And so I keyed in the word marketing, but it is going to replace it with sales. And that would happen immediately. So what is the employee department? Marketing. It's going to go through the set, and it's going to say, nope, the employee ID is 10. So the department is sales. And then we enter the first and last name of the employee, and then it prints it out. And you can see that it printed department equals sales. For the next employee, their number is well above our 200 limit. And the department is accounting. And we did the first and last name. and when it printed it out, it did keep their department because it was greater than the 200 limit. Here is another example. And for this one, the scenario is that you have a child and they want to go on the elementary playground, and we have to see if they're old enough. So, in order to play on the elementary playground, you have to be 5 years old or older. So, we've got the first and last name. These are public properties. We have the age, which is also property. And then we have special logic for elementary playground, which is a Boolean. So it can be true or false, meaning if it's true, they get to play on the elementary playground, and if it's false, they do not. So in our set, we are going to check the age. And if the age is less than 5, then elementary playground is false. Otherwise, elementary playground is true. And once the age gets set, okay, it'll go through this code and it'll set elementary playground. So for our object, we are creating child. So that child object is an object of the Fun Day class. And it says enter their first name. So we use console.readline and we store it directly into child.firstname. And for the last name, same thing. Read it from the console, store it directly into child.lastname. And then for age, we are declaring a temporary integer, asking them to enter the child's age. And then you'll notice that we haven't read in the age yet. So I incorporated that console.readline into the try parse. So we've got int.try parse, and then we've got console.readline. So it's going to read the age right here and use that as input into int.try parse. So if it can take the string and convert it over into an integer, it will store it in temp age. And if it can't, then it's going to come into this error handling loop and it's going to say, please enter a valid name without decimal places. And then we'll come up here again. It'll do the console.readline, take the value, run it through int.try parse. And if it can do the conversion, it stores it as temp age. So by the time we fall out of this loop, temp age will have a valid number, and we assign that number to our child object.age. Okay, and at this point, it is going to go ahead and set elementary playground because we have an age, so it's going to run through that code. And so we can say if child.elementary playground. And how that reads is child.elementary playground equals true. If that is true, then it's going to write a little message that the child is old enough. If that is false, then they're going to write a message that the child has to use the preschool playground instead of the elementary playground. And here you can see some sample output. So we got a little girl named Cookie Crumb, and she is 4. So knowing that, it would have come through here, and elementary playground is going to be false. So once we enter the 4, it sets the Boolean to false, and then it prints out Cookie Crumb may use the preschool playground instead of the elementary. And I did a little variation of this for an example of a get method that would have to be coded out. And the only circumstances I could think is if you wanted the data formatted a little bit differently. And so what I'm doing with first and last name is that as long as it's not null, I am converting it to uppercase and returning it. And I'm doing the same thing for last name. Okay. Here's last name, got first name. And then for the set, remember that there is no parameter list here. C# automatically creates a variable called value, and that is storing the data that was passed to first name in an assignment statement. Okay, so value represents the value that we are trying to assign. So as long as that is not null or empty, then we're going to do the assignment. We're going to take value and put it into first name. Otherwise, we are going to assign string.empty to first name. And last name works the same way. And then here's our special logic for elementary playground. You see there's no special logic for age. That's just a straight auto implemented property. For elementary playground, we've got the private field, we've got the public property. And for get, we're just returning that elementary field's value. And for set, we are checking age. And if it is less than 5, we are setting a value of false. Otherwise, we set a value of true. And if you read through this, you can see we do have a child object again. And so here we've got a read line, and we're assigning child.firstName. Here we have, the prompt. We have a read line that assigns child.lastName. And for the age, we're storing it in a temporary integer, assuming that it can read the string in. That string can be converted into an integer. Okay, then it'll go into temp age. Otherwise, it's just going to keep displaying the error message and making them, type in the whole number. And then we take the temporary age, store it in child.age. It will run through the playground variable. And then we're checking child.elementary playground to see if that is true. And if it is, we print the message. Otherwise, we print the other message about using the preschool playground. So to summarize, in both regular and auto-implemented syntax, the private field is hidden. You can only access that through get and set methods. And so the difference is that in regular property syntax, you have to code out the get and the set. And normally in the auto implemented, we don't have to code it out. We just have to use get colon or semicolon and set semicolon. Now, if we really wanted to encapsulate our data, because using private fields does encapsulate our data, it hides the data from the programs that are using it because they don't have direct access to the data. But if we really wanted to encapsulate the data, we could put our classes in separate files. And I will show you what that looks like. So you will always have program.cs, but C# lets you add additional classes. So you can right click on the project name, go to add, and go to class. And then you key in your class just like normal. If it's in the same namespace, it'll automatically be included in program.cs. If the namespace is different, then you actually need a using statement that will pull in your code. And our namespaces are different. This has a namespace of playground. And if you look, the main method, the class that's in whole contains our main method. The namespace is called elementary use. So 2 different namespaces. That is why we have using playground above it. And that's really all you need to do to include a different class. Because when you run the build, you will have access to that class. And I have one more example, and this shows you fields that have been converted over into properties. And so you are going to have an exercise in your assignment like this. And really, if they're private fields, what you need to do is you need to change private to public. You have to get rid of the underscore, and then you have to add curly braces with set, semicolon, and get, semicolon. And that is exactly what I did here. And then you'll have to go through your code and make those adjustments by getting rid of the underscore and just leaving your property name. The get and the set methods you can delete. You will notice here I've kept the constructors. I kept a method to create the full name with the first and last name, but all the other methods I got rid of. Okay, you will not need the get and set methods because C# is going to generate them. In your main method, you do need to create an object because it's the object that can access the properties. Okay, so here I'm using a parameterized constructor that accepts past data. And then I am printing the data out using the object.property. For this one, I kind of alluded to this example at the beginning. For this example, we have a couple of properties or fields that are dependent on other ones. So we have some special logic in the set. So first we'll look at the original program. We've got 4 private fields: price, already assigned, quantity, and reorder. And you can see that the constructor is giving them default values. And then we have get and set methods for each one. The get methods are all pretty straightforward. There is no special logic in them. We're just returning the value that's stored in that field. The set methods for price, and I believe it is quantity, have some special logic. For price, we only want to assign the price once per object. So we are checking already assigned. So if already assigned is not true, which means if it's false, then put the value into price and set already assigned to true. For the quantity, if the value is greater than or equal to 10 or to 0, put the value into the quantity. Then we have an if to check the value to see if it is less than 10. If that is true, reorder needs to be set to true. And this is very similar to what we were looking at before. The one on the left, we have to create an object. And then we have to use the object to call set price. We have to use the object to call set quantity. And then we are calling a static method called print goods. And we are passing it our object. And then down here in print goods, we have to use the object, which is called P, to call the get methods. And that is how we are printing out the data. Over on the right, we are now using properties. And so we no longer have to use get and set methods. So we still have to create an object. But then instead of calling a set method, we just call product.price. And then we set that equal to whatever they read from the console. And then we prompt for quantity, set that equal to whatever we read from the console. And then we're going to print out the information. Okay, and print goods is a static method. So that is located here. And there is yet another example. And this is another one where we're converting from private to public. So hopefully you guys have picked up on the fact that you're going to have to do this on an assignment. So maybe the easiest way for you guys to see how to do this is if you watch me convert it. So hold on, I'm going to copy this. Alrighty, so I went ahead and copied the code on the left, which is using private fields instead of properties. Okay, and we can run this. Okay, and if we look down here, you can see we're using the set methods to set the values, and then we're using the get methods to retrieve them. So how do we convert this? Well, these need to be public properties. And so first I'm going to change private to public. And these also need get and set. And these are normally on separate lines, so I'm going to put them on separate lines. Add in the get and set. Department name, and we can still initialize to string empty. We do need to get the get and the set in here. Oops. There we go, almost done. All right, so now we don't need any of these get and set that we had before, but I am going to keep department because that has some special logic in it. And here are some more. Where do they end? Okay, they end right here. All righty. Now for this one. Okay, so it is department that we're doing this on. Let me move this down here. So we're going to have to make this one private. Oop. And I'm going to go with lowercase so I don't have to change too much down here. And we'll get rid of the get set because the get set is going to be coded. All right, so this is going to be int department. And we are not going to have this. We need an opening and a closing curly. And then inside, we have to do a get with an opening and closing curly. And we also need to have a set with an opening and closing curly. So the get is going to be simple enough. We just return that private field. Okay, so the set. This is going to have to change because C# generates value to store what is passed to the set method. Okay, so that has to change. And I think I'm going to do a switch on value. And let's move this. That's why it's flagging errors, because I need to put the closing brace below my switch. Okay, and this is no longer a private field. It is a public property. So I got to change this. Okay, so that should all be good. Okay, down here. Now you see it's how it's calling all of the sets. So we don't have sets anymore. And so that data that we have in parentheses should not be in parentheses. We just are going to set it equal to that value. Okay, so that takes care of assigning values to the properties. Now we are going to print them out. And so we still need our employee object, but now we can just use the property. We are not using a method. So we're going to get rid of the parentheses. We are just going to include our property here. So I'm getting rid of the method calls and only including the property name. Oops. Alrighty, so let's run this. It should look the same when it runs. So just to kind of remind you, where'd my old one go? I think it's still here. Here it is. This is my old one. And now when we run it, it should look the same as soon as we get rid of my typos. Let me see. Oh, I believe I'm missing a curly brace. Let's see. Public class employee. That should be for department. That should be for employee. Okay, that is for the set. Yes, I definitely am missing one. There. Got the switch, we got the set. We have department, got our class. All right, everything should be good. Now, if this happens where they get kind of off, you can always go to edit and format document, and it should kind of move your code around so that you can match things up better. Let's try it again. All right, so we did in fact get the same output after all of that work. Okay, but that is how you would convert it over. You can see it's a lot less coding with properties than it is with fields. So static fields and static classes. So far, we have worked with static methods, and static methods do not require an object to call them. That was what we have been doing for the last several weeks. The main method is a static method. And now you're going to learn about static classes and static fields. Static fields are extremely useful if you want to accumulate totals amongst all of the objects. Normally, when you create an object, every single property or every field is duplicated, and they're all separate from each other. They do not share data. A static field lets you share the field among all of the objects, which is useful if you wanted to tally the number of transactions, or if you wanted, maybe if it's your bank and you wanted to total up deposits for the day or withdrawals for the day, something like that. You would need to have a static field. And a static field can be used for private or public, and you can also have it with properties. And so what we're going to do is kind of take a look at how to create one of these fields and how to access it. So to create it, all you have to do is put the keyword static in, and it becomes a static field. And I will show you an example. So this is a very simple account class. You can see that I have a transactions property that I set to 0, and then I have account name. And then I've just got a little print method. Okay. And then in the program, I create a object called first, and I assign account name, and I add one to transactions. And then I print out a little summary. Okay. And for the second object, I name it second, very original. And then I let them enter a name from the council. And of course, then because they're entering from the council, I got to make sure that it's valid. So I validate it. And then I add one to transactions. And then I print it. And so you might think, well, that would be the second transaction. But that is not how it works with regular properties. What happens when I create each of these, okay, and I will show you, is the first one, which I called very creatively first. So the transactions on this are going to be 1 because I added 1. And then the account name is Fred Flintstone. The second one, which I called second, also has transactions, and it has an account name. And the account name, I think I entered in the example, was Bam Bam Rubble. Okay. And it adds 1 to the transactions, but these are independent of each other. So when the second object was created, transactions is set to 0. So when I add 1 to it down here, well, transaction is going to be 1. And then Bet you can't guess what the next one is. Yes, this one is called third. And we have transactions and we've got account name. And for this account name, we are using Betty Rubble. And transactions get set to 0 when the object is created. And then you can see we add 1. So when it prints, it is going to print transaction 1 for each of these objects. And that is not what we want. We want, when it adds 2 transactions, when it adds this one, it puts the 1 in there, and then it adds this one, we would like transactions to be 2. And then when it adds this one, we want transactions to be 3. And we can do that with a static field. So over on this side is the remake. And all I have done is put the keyword static in here. Okay, everything else is the same. But how that field is processed is going to be different because now every account does not have transactions. They share it. So it's almost like you could kind of visualize it over here. It is shared by all 3. So they all have access to transactions. So it starts out at 0, and we add 1. And then we come down here, we read in bam, bam. It adds another 1. So now it becomes 2. We come down here, we've got Betty Rubble. We add another 1, and it becomes 3. So when this third one prints out, it is going to print a 3. So as you can see, we've got 1, 2, and 3. And that is the benefit of using a static field. We have already used static methods. And if you remember, that just involved putting the keyword static in the method signature, which is the first line of the method. You can also create static constructors. Static constructors are only used to initialize static fields. And you can initialize a static field really in 2 different ways. You can either set it equal to 0, which is what we did with transactions. Let me see if I can find it. See how we set it equal to 0? You can do that, or you can create a constructor. But a static constructor can only initialize a static field. And remember, it has a default constructor. So the only reason I would ever code a static constructor is if I had a lot of properties and I had a parameterized constructor and I already had a static constructor, or not a static, a regular constructor, then I would probably code my own static constructor. But it works kind of the same way. So it's going to be public. You have to put the keyword static in there, the class name. Got nothing being passed. And the only field or property that you can initialize is the static one. And then you have to code the other default constructor, which obviously is not going to be static. And that makes these unique. So it's going to know that this is different from this. And in this little small class, all we've got is account name. Oops, got to spell this right. Okay, so that would be how you would do it. And we've already created quite a few static methods. And so far, when we have used static methods, they have been in the same class as our main method. And that is what this example shows. So we've got our static main method, and below that we have another static method called cube. And so calling cube doesn't require any special code. We can just, call the method and pass it whatever data it needs. Okay, so anytime you want to call a static method that is in the same class, no issues. But what if you want to call a static method that is in a different class? And that is the case here. So I've got a class called calculations, and then I have a class called program. These are two different classes. So if I'm in the main method and I want to call cube, I have to prefix cube with the class name. That is the only way I can call it, because I have to tell C# what class that static method is in. So a couple things to remember. Static methods do not require an object to call them. A private static method can only be accessed within the same class, so it doesn't require the class name prefix, right? Private can only be in the same class. A public static method can be accessed from any class. So if you are trying to access the method from a different class, you do need to prefix it with the class name. And there are examples. So here we've got our main method, and then we have three different static methods: find max, find min, and cube. They all happen to be in the exact same class. So this is the simplest case where you just use the method name, pass it the data that it needs. This example takes those same three methods and it throws them into a different class named calculations. So now we have a calculation class and we have a program class. So now they are not in the same class, and we have to prefix each one with calculations, which is the name of the class. Static constructors. I just kind of walked through how a simple one would look, and now you're going to get to see a little bit more complicated one. And so the one I showed you had properties, and this one has private fields. So it's the same concept for both. A static constructor can only initialize static fields. Okay, so that is the only thing that can be in here. Okay, and then this is the other default constructor, and it initializes everything else. The last thing that we need to talk about are static classes. So static classes are a little different in that we actually don't create objects. So they are classes that we can use without creating an object. So they are not instantiated. Okay, so we don't use the keyword new, and we do not create an object. All of the fields and properties in a static class are static. All of the methods in a static class are static. The only constructor that is allowed is the default constructor, and that sets everything to zeros or null. These classes are useful for utility programs, things that are not going to change. Some of the math class methods that we have used come from a static class. Okay, and system.convert, some of those conversion methods are also examples of static classes. Okay, and this little table does summarize, or this little example kind of summarizes the difference between a static and a non-static class. So this first class is not static, which means you have to create an object. So this is a college student class. We only have two fields, ID and name. This is a static class called student. And we have two fields, ID and name, and they are static. You will also notice that every single method is static. So how do we use something in student versus college student? If we're going to use student, that doesn't have to have an object. So we just use the class name, a dot, and the field. If we are going to use college student, that does need an object. So we have to say new student equals new college student. And then we use the object dot property to assign values and to retrieve data. Okay, so that is the difference. If it is a static class, you do not create an object, you just use the class name and then a dot and the field or property. Okay, if it is a regular class, I think you guys are familiar with how to add data by now. If it's a private field, we have to use the set method. We have to use get to retrieve. If it's public, it's just the object dot and then the field. If it's a property, we are going to use the object dot and the property. So we code it similar to the way that we code a public field. If you guys need more examples on that, the static classes, let me know. Because it is a little bit weird because all along we've been doing objects and a static class does not use an object. And you can see it's not used a lot. I mean, utility classes and some of the math class, system.convert class, it's not used all that often. So when we got into working with classes and objects and properties, we did utilize some object-oriented programming concepts. And so we're going to kind of summarize what these concepts are. And the first one is abstraction, which basically means that we can use a class, we can use the methods that are in a class without knowing how they are coded. So it's kind of like you can go to your car and you can turn it on without knowing how your engine runs. Okay, you don't have to know what's going on with the pistons and all of that. So that is abstraction. And so we deal with abstraction on a daily basis, right? I mean, unless you built a microwave, you don't really know how it works, but yet we cook our food in there. So it's basically hiding the internal details of the class from the developers that are using it. Like we need to know the name of the method, we need to know what to pass it, but we don't need to know how that method works. We don't need to know what it does with the data. Data hiding is part of abstraction because we don't need to know how the method works. We don't need to know what the fields are. We don't need to know if they create additional variables. We don't need to know if they're using properties. We don't need to know any of that. All of that is hidden. So data hiding is part of abstraction. The focus is on security. So when we define class fields or methods as private, they are hidden from programs that are outside the class. You can use the class, okay, but you are not going to know the inner workings of the class. And you're not necessarily going to know how many fields there are, what those fields are named, or even the kind of data that's stored in them. Encapsulation. So encapsulation is also related to data hiding, but the focus is on hiding the program's complexity by using access modifiers like private and public. Okay, so obviously if we use public, nothing is hidden, and private it is. Okay, so encapsulation allows us to control what other programmers have access to. So any relevant information we can make public so they can see it, but we can hide all of the rest. So we can hide groups of fields, properties, methods. Um, and when you encapsulate, it does appear that all of the code behind the scenes is one unit or one object. So when we create an object, like we have, we are encapsulating because then when we add data, it kind of appears that in this case, employee is a single unit, when in fact, employee is made up of multiple properties. So how is encapsulation different from data hiding? Data hiding is all about security, okay? And encapsulation is about hiding the complexity of the program. You don't need to know all the inner workings of the program, okay? And so that is the primary difference. Polymorphism is another object-oriented concept. In object-oriented programming, we can have methods with the same name. And the way C# tells them apart is by the signatures. The data that is passed has to be different. Okay, and you will see as we move through the wonderful world of C# that not only are methods having the same names, but they do it all the time with arithmetic operators. Okay, so your plus sign, your minus sign, those can take on multiple meanings as well. So with polymorphism, you could actually create a library of methods that would handle any data type. So if I wanted to do this with find max, I could create 3 different methods, all called find max, and they could handle different data types.